In this video, we're going to continue with our problem solving using the law of conservation of momentum. And the next problem type we'll deal with will be collisions between a moving vehicle and another vehicle moving in the same direction. In example 2, we're looking at vehicles that are moving in the same direction. They're going to collide and they're going to stick together. So that means we're going to use this modified equation where we have the final velocity of the combined masses. So we've got a velocity of the combined masses. So let's start by reading and annotating the problem. So we've got a 400-gram collision trolley. So we'll call this mass of A, moving at 1.5 meters per second towards the right. So we've got the initial velocity of A and it's moving. So right is positive and left is going to be a negative value. So it's going to collide with an identical trolley moving at 0.5 meters per second in the same direction. So it's going also towards the right. And its mass, because it's identical, is also 400 grams. So this is our initial velocity of B. The trolleys stick together on collision. So that means we combine the masses and we have the final velocity of the combined masses. Okay, so we'll just use V subscript C for that one. So let's go on and annotate our diagram. Okay, so I've gone and annotated the sketch with the before collision, after collision. I've got my combined masses afterwards and my velocity of my combined masses, which is the unknown. So let's now plug that into our formula and calculate the final velocity. So now let's substitute our values and then solve. And because it's a positive value, we know the direction is to the right. And let's just do a final check here for this value. Does that make sense? So we had the initial velocity of vehicle A is 1.5, so we know it's going to be less than that. And we've got the initial velocity of vehicle B, and it's 0.5, so we know it's going to be more than that because it's being collided with from in the same direction from another vehicle. So I'd say that makes sense. Moving on to example 3, we've got vehicles both moving in the same direction. They collide and they either keep going in the same direction or they rebound. So we need to determine, and this is where our signs will come in. So if we've got an object that has a positive value in the end, it indicates its velocity is to the right. If we get a negative value, it will indicate that it's moving towards the left. Okay, so again, we'll go through and annotate our problem. So again, so the first trolley rebounds at 0.5 meters per second. So that means we've got the final velocity of A is negative 0.5 meters per second. So that's important to make sure you get those directions correct. So we want to calculate the velocity of the second trolley. So the next step again is to sketch and annotate the diagram, making sure that you get those values correct. So particularly the velocity afterwards. So we know that the velocity of A we know that the trolley A rebounds, so its initial direction is to the right and then its final direction is to the left. So that means we need to make sure we put that negative value in there. So when you do your calculations, you've got to keep that one in mind. Okay, so then that way we can determine, is this going to be which direction? Well, it's likely it will be in the positive direction, or we'll see. Okay, so we'll go on and do the calculations. So again, we start with our correct formula that we're going to use, and then we substitute and solve. Okay, so don't forget that we've got this negative value here when you do your calculation. So notice what happens at this point. We've got 1, and then we have to plus both sides, so we end up with, and because it's positive value, we know the direction is to the right. Our next example is going to deal with collisions between a moving vehicle and another vehicle moving in the opposite direction. So again, annotating the problem, making sure that we identify what the positive direction. So east is positive and west is negative. So that means when we look at vehicle B, it's moving in a westerly direction. So we need to make sure that we put its initial velocity as minus 4.0. And if we look at after the collision, the velocity of A rebounds. So if it's initially going easterly, its final velocity direction is to the west or negative. So again, make sure when you substitute those values that you don't ignore the negative signs. Okay, I know some of my notes, I should have probably written that as negative. Okay, so make sure you've got the right direction here and that we've got the rebound direction for the velocity afterwards for vehicle A. And this is what we're trying to determine. So let's carefully substitute our values in. Don't forget this is negative, and again, going to write this out a bit more in full. Whoops. So this one will be 250 plus this if we move it to this side. Okay, and because that's a positive value after calculation, we know that the direction is to the east.